Hi, I'm Michael. I'm working for 7lab, and as Chris mentioned, I'll talk a little bit about how we ported the latest version of Android to a device from Advantech, which did not support the latest version of Android, and why we did that and how we did that. The information here is hopefully generic and applicable to other devices, but of course I'll use the device we did this on as an example. Yeah, so the first question you might ask, why this hardware specifically? We could have also chosen something easier maybe. The key point here is we have a customer which works in the automation industry, and for regulatory reasons, they have to know exactly which software runs on which device, and there also needs to be a update log, so a software update log. That of course means you need secure boot and the whole chain like for that, and you also want the software to be reasonably secure. And of course, an I don't know 5-year-old version of Android without official secure boot support in the BSP does not fit that requirement. And so why did they choose this hardware? Just because the hardware itself looks interesting. So it has a reasonable price and has all the features they needed. So if we would be able to get the software working in a way we wanted to, then this would be the perfect thing to choose. And that's exactly what we did. And yeah, here you can see basically the reason why we had to do this. So the official version was Android 10 at the time. There's also Android 13, but we did not have access to that. And we did that at a time where 15 was the latest version. Right now there's 16 out, but we did this a while back, so we are mostly talking about Android 15 here. Yeah, so what does the device look like? Basically just a display with some ports. So there's none of the fancy features that more connected or devices or smartphones have. So there's like no modem, no Wi-Fi, no camera, nothing like that. It's really just a display for displaying stuff. And it has an Ethernet port for network, and actually 2 Ethernet ports. 2 serial ports for some kind of bus connection, for example, CAN, 2 USB ports and power, and internally you can see, of course, the usual stuff like the SoC. In this case, it's from NXP. This is important. I'll get to that later. We have the eMMC, which is also very important for secure boot, because this basically allows for Android security module with our PMB, which is basically storing data securely inside a special portion of the eMMC, and of course the RAM. And you also see the debug keyword port and the boot config. The debug keyword port was not documented by Advantech at all, so I just probed it using a logic analyzer until I found it. The boot config is also not fully documented. They just tell you how you can select between SD card boot and eMMC boot. And I basically use that by removing the SD card, selecting the SD card boot, and then I end up in the boot ROM, which is of course important to be able to flash the device initially with whatever software you want to flash. Yeah. So the first thing we did then was we checked. So we had, of course, the Android 10 BSP from Advantech, and the first thing we did was to just look at what they changed there. So we just took try to find out which version of Android they used as a base. They used the NXP branch or the NXP port of Android 10 at a specific revision, and did some changes there. And what we found out was they just added device trees for the bootloader and the Linux kernel. They added a couple new drivers for devices which were not mainline, specifically one of the Ethernet ports, the EEPROM, and the display panel, among a few other things. In U-Boot, they had, I think, the most customizations because they had like a full board, very custom board initialization, which is very common actually. But of course, if we want to port the latest version of everything, we need to understand that and port that to the latest version of the bootloader, in this case U-Boot. They basically just do like all kinds of GPO initializations there for hardware, which is somewhere on the board. For example, the panel needs some GPIOs and power on GPIO set and to be able to power this on. And some minor hacks all over the place, basically. For example, in the Linux Ethernet driver, they had some custom way to configure the LED. And there were some minor workarounds, stuff like that. The biggest chunk by far was like very lots of changes in Android itself in the portions which are completely unrelated to the hardware in any way. So they basically built their own distro or tried to do it. This is good because we don't need these changes at all because that's simply not interested in that. Even if we needed a feature, we thought this wasn't high quality enough for us. We would have done it ourselves anyway. And so once you have that, you can categorize those changes. And the first and important one is, of course, the port for hardware, which we need. So we have to have the device trees. We have to have all the drivers in there. But only for the devices we want to support, because in our case, we didn't have to support everything because we didn't use all the hardware features. That's the second category, support for hardware which we don't need. We can simply skip that. And then, of course, the generic customizations, which we just drop completely. And what's in which category is, of course, up to you and your customer and your project. And it's also an interesting thing we saw that some changes Advantech did were simply not needed in the latest version of Android anymore because they have been mainlined in the meantime. For example, the NTFS file system is something I remember seeing there, but also other things are currently not in my mind. And here you can see what we actually did. So the green parts are the things we needed, and the orange striped parts are the ones which we skipped because we did not need that. And those were USB CAN. We didn't have that bus. We had an external RTC, which is different from the SoC's internal RTC, which we didn't need. They had a separate MCU as an external watchdog. We just used the SoC's watchdog. And they had an actual TPM, which is usually not needed for Android because that's not how Android security model works, because they heavily rely on VRPMB area on the eMMC, which I mentioned before, and combine that with secure build and the trusty secure execution environment. So where did we start? There are actually a couple places where you can start. So, for example, you can start completely from scratch. So throw away everything and start with a bootloader, basically. That would work, but we didn't do that because we wanted to get to basically to the lock screen with our own port as soon as possible, so you can see something, which is always fun, and also quickly know if what you're doing is working or this is completely crazy and we shouldn't do that. So where we did actually start was basically with the kernel and Android at the same time, but we just copy and pasted the old device trees into the new kernel and modified them according to some of the kernel changes. And we kept the old bootloader, and of course that meant we have to do some hacks to get the new version of Android working on the old bootloader. For example, we had to disable Android verify boot. We had to add a few custom command line parameters, which which newer versions of the bootloader add automatically. But that was very minor, and you can just iterate through that to see what's needed, and then it boots after you added 2 or 3 parameters. So that's definitely, after the fact, I can still say that I would recommend doing this way, because it gets you to the goal pretty quickly, and you don't have to understand the hardware from the beginning. You can just try what works and then improve on it later. So how did I actually get to the first boot? As I said, the first point I already said, we added some hacks for the old bootloader. Then basically just copy pasted the panel driver, the display panel driver from Advantech, and copied it into the new kernel. They did not add a new driver, they simply modified an existing driver. So I just replaced it as a first attempt to get this working. Of course, this should get cleaned up later, and I did that, and I get to that later. And I also had to modify the Linux kernel config to enable the drivers we need. That's usually was stuff like the display panel, our backlight driver, and all the like powering dependencies of that, like regulators, PWM, clocks, and stuff like that. And of course, as I mentioned, I disabled Android verified boot because that didn't work at this point. And interesting issues we had were definitely debugging mounting partitions in Android. They have this, I think it's called a FS manager or something like that, and this doesn't really have locks in the places you want locks to be. So if you misconfigured the partition mount points, or Android verified boot isn't working correctly, then it just times out for some reason, and you don't know why. So I basically just added a ton of my own logs until I knew what the issue was. The second issue is, in this case, hardware specific, not hardware specific, but specific to the port that Advantech did. So I had a weird UART behavior, and it turns out they configured the correct pins in the bootloader, but the wrong pins in the kernel. And as soon as the kernel took over, weird things happened. It kind of still worked, but not always. And yeah, it was a little bit weird behavior, but after I figured that out, that was working fine. And of course, here the issue would have been easier if I would have had schematics for the board, which I did not have. So I just had to trust that one of those configurations was correct, and just had to figure out which one it was. And now we're at the point where we actually had the Android port running, so we could boot into the lock screen. All the drivers we needed were running. We had touch, we had the display, you could interact with the device, and everything was working. But now, of course, this was done in a very, it was the first attempt, and the code didn't really look well, and we modified stuff all over the place. And now it's time to go further and clean stuff up. And the first part of that was porting the latest U-boot version. So if we can actually get things running properly, so we can remove our hacks, and we can attempt to enable secure boot. And as I said before, they had some initialization sequence there for GPIOs. We just copy and pasted that into. So basically, what I forgot to mention, all of the software we wrote, we basically always based off the official development kit from NXP, the SoC manufacturer, for the exact same SoC that the Advantech device has. So our goal was always to stay as close as possible to the dev kits, so we can understand which differences there are between these two devices, because that makes it actually very easy to later update to newer versions of Android, because you can just check, okay, what did NXP change here? Okay, then we do just do the same if we need it, otherwise we ignore it. And so yeah, in this case too, we based on the dev kit, and we just changed the pin configs, replaced the device tree, added this GPIO initialization sequence from Advantech, And they also had a special way to bring up the panel, basically a very hacky way that I don't want to get into because I later cleaned it up anyway. And they also copy the Ethernet MAC address from an SPI flash into the device tree because they are stored in a non-standard way. Yeah, and once we had that, we didn't need any of these device tree or CMD line hacks anymore, and we could enable secure boot. And now it was time to do actual cleanup of the code for all of it, like the bootloader, the kernel, and the Android itself. Yeah, the first step is of course to rename everything from the devkit files to our own device and put it in a separate Git directory where we have our changes, and so we don't have to modify other projects' code anymore. Then we clean that up from stuff that we don't actually support, like devkit variants, camera, audio, stuff like that. Audio can't be removed fully because this is very deep in Android, at least with the NXP HAL. But it doesn't matter if it's there and it's not used. It doesn't do much harm, so that's fine. And yeah, and we had NXP's tools for generating the final images specifically for the bootloaders and secure boot weren't really very generic enough. So we had to add basically our new device name into all these switch cases, so they can still build those images from for our new device name. Yeah, and at this point we could have stopped because everything was working and relatively clean, but we wanted to go a little bit further. And the biggest thing was probably the first 2 points. The first one is the panel. I completely rewrote the panel driver because this panel simple.c file is actually like a catch-all driver from the Linux mainline kernel, where the port basically every panel that can be initialized simply by sending a certain power up sequence. And there's like maybe 50 or 100 panel drivers in there. Like, this file is like several thousand lines big, and the panel isn't actually that simple. They had to add like lots of if defs all over the place to do special things that this driver didn't support. And after I basically removed everything except for their panel, the driver was just a couple hundred lines long, and yeah, I just moved it to a new file, which is also nice because I then can use compile this as a separate kernel module, which doesn't conflict with any existing driver, and I then can load this into a generic kernel image, which is Google's newer way to attempt to make the kernel a bit more modular, so you can just load a generic kernel and then load all the kernel modules from the vendor and product partitions, and so you don't have to modify the core kernel parts anymore. And then I completely rewrote the device trees, which I initially copied from Advantech. So I basically just modified the Advantech device trees until they looked as much as the dev kits as possible. So I could see like the actual differences. And then I cleaned up some of those differences, and yeah, then I stuck with that. So these are very close now. They're easy to compare, and when there are updates, it's easy for me to check if I need those updates and take them in or drop them. And yeah, I've mentioned the third point already. We were able to enable AVB, which is Android Verified Boot, which is basically everything from Android itself, which comes after the SoC's custom secure boot chain, which is verifying signatures of the Android images, like the kernel and the partition, and the read-only partitions, and also later stages that come after that. And HABB4 is basically NXP's secure boot implementation, which starts at the boot ROM to verify the bootloader and goes up to the kernel, excluding the kernel. And this actually blows fuses in the hardware. And of course, I initially blew the fuses in the wrong order. So maybe important learning here: enable RPMB before you enable secure boot, because if you do it the wrong or other way around, then you can't enable secure boot anymore due to the way they derive the keys. And yeah, I had to get a new device to continue my work. So more reading here in preparation is always a good idea before actually blowing fuses to enable secure boot. Yeah. Yeah. I'm not going to any details in the secure boot of NXP here, because that would be a whole different topic, and I'm also not really an expert. I just read documentation for a very long time, apparently not long enough, until I understood enough to get it working. But yeah, the nice thing about this is that this information is completely public. So you can actually do this without an NDA, unlike most other SoC manufacturers. There are some GitLab repositories and also some public PDFs. It takes a long time to understand them, but actually doing it is actually like 3 or 4 commands in the bootloader shell, and you're done. It's actually quite easy. And yeah, you don't need an NDA, which is quite nice. And now I have a little video, a very short one, which shows the boot process. So you can see what the device looks like and see the logs scroll by. I know if it's readable, but here you can basically see that the bootloader verifies the next status. So you can see secure boot is active. And here you can also see the boot logo from the bootloader, which previously wasn't possible because I didn't have a panel driver for U-boot, which I also wrote myself after I've done that for Linux. And yeah, in the top log is just the debug keyword, and the bottom log is logcat, which will become active as soon as logcat is available. And then it starts booting. Of course, you know that it's nothing new to you, I guess. We did implement a kiosk mode here, but I didn't do that properly at the point of I recorded this video. So there's like a 30-second delay where nothing happens due to a timeout bug. But yeah, after that, you boot directly into a web application. It's just an application which shows a website, which is all our customer needed, as a form of kiosk mode. And yeah, this is then maybe seek forward a little bit. Yeah, in this case, as a demo, I just opened the Wikipedia page for a kiosk. And yeah, this is running Android 15 with the whole secure boot chain, which is what we wanted. That's what it looked like. Here you can see the Android version. Yeah. And a few statistics for this. What did we actually change in the code? We added a couple new files for the new board. Usually you wouldn't have to modify that many files in the bootloader, but I had to do some tree-wide change to allow patching the device tree from a board instead of an SoC to properly support the display panel we use, because they actually detect which panel is in use using a jumper, not a jumper, a dip switch. And then you have to tell the Linux kernel somehow which panel it is. And Advantech did that by patching some custom bytecode for initialization commands into the device tree. I simply let that do the kernel drivers and just change the compatible value. So basically change which driver gets loaded, which I found to be much cleaner and easier to update. And then in the kernel, we only added device trees and of course the panel driver. and yeah, modified the configuration to add the drivers which we needed. And now the important or most interesting questions maybe is, should you do this, and if yes, when? And this basically my opinion on this after having done this. So of course you should only do this if the SoC vendor gives you a complete publicly available and maintained BSP for the SoC, ideally even their dev kit if they have one. Because if you have, for example, like a Qualcomm or MediaTek thing where you can't get the source officially, or you have to use binaries files and try to get them working, which is basically what you do like in LineageS and open source work when you don't have access to these files, then there's of course much more work and much less guaranteed to work, especially for newer Android versions. So NXP is actually the ideal case here because everything on the Android side is open source except for a few binaries for stuff like the GPU firmware and so on. But these are usually parts you don't have to modify, or at least that we didn't have to modify. So we didn't need the sources for that. So everything that we did have to modify was open to us. And of course, you have to understand the board schematics, not technically the schematics, but you have to understand the board well enough for you to, maintain the port. But usually it's enough to read the device trees from the Linux kernel and U-boot to understand the hardware. So if you have a device tree or at least an older port, then this should be good enough. And as I mentioned, closed source paths must not be modified for your project, because if you don't have access to them, then you can't do that. And closed here doesn't necessarily mean close to the public, but close to you. So if you actually have an NDA, which we did not have, then that's not an issue for you. Then you can go ahead and do that. But if not, you might have a very hard time, and maybe you should rather choose a different hardware. And yeah, that's my conclusion. And that concludes the presentation.
Okay, Michael, fantastic. Thank you very much. Yeah, I've been through that process a couple of times. So a bunch of people are queuing up to ask questions. So I'm not sure where to go. I think Stefan Gutz was the first person who put a hand up some little while back.
Yeah, that was an accident, actually. I don't have any questions. I knew the content beforehand.
Okay. Who else? Syed?
Yeah, sorry, it was just my mistake. I want to clap. Thank you.
Okay, somebody else.
I have a question, but I don't know if I am in line or I'm getting in line.
Go ahead.
I had a question on, Michael, you in your earlier schematics, you showed a USB-based CAN bus controller, the SJA1000.
Yes.
Could you shed some light? Like, is this device, going to get embedded on automotive cars? Like, what's the use case behind this device? Like, where it's getting used?
Well, I don't know. So this is basically finished product by Advantech. So I guess they have looked at the market, what their customers need, and built something that fits most of them. I don't know personally what this is used, but I guess that it's supposed to be connected to devices where you have like a CAN bus. I don't know, maybe in a car, maybe also just in the building where you could connect this to, and so you can talk to this and present the information or control the devices on this display. But I don't actually know that.
Got it. Thanks. Yeah, the CAN bus controller definitely intrigued me because it's mostly present in devices which are in infotainment systems in the cars.
Yeah.
So thanks.
If I can just butt in there for a moment. In my experience, the USB CAN bus controllers are great for debugging and proof of concept and such like. I'm not so sure they would be used in production, but I could be wrong. I've only ever used them just for basically just playing around and doing quick demos.
So from what I know regarding CAN bus controllers, or they integrate with different ECUs in cars, like so that the Android side can communicate with the other things in the cars. Like if you press a brake, then a signal gets sent out in the CAN bus. The Android side listens to it. So that's what was I found that curious, because I wonder if maybe that's one of the use cases of the device.
If I can maybe add to that, like Advantech just produces like a whole bunch of off-the-shelf, very affordably priced hardware. In this case, these are like pedal PCs for industrial automation purposes. And normally, I mean, how these devices come to light, somebody approached them and said like, "Oh, we needed to this and that spec," and probably someone that was willing to buy some devices said we need CAN, and then it was integrated. Like the portfolio of Advantech is very large, so they build all kind of like all permutations of devices basically.
I did run into one of Advantech devices at work when I was at Esper. So I know Advantech as a company. I work with a couple of devices of theirs.
Yeah. There's also one question in the chat from Johann S. Thanks for a very interesting presentation, Michael. How long time did this adoption take from start to production ready, and how many people worked on this?
Yeah, basically, I worked on this and had some smaller testing help from one other person. The total time, I would say, up to the point where the board itself was supported with Secure Boot was maybe about 4 weeks. But there might have been some overtime days in there. So, yeah. So I think with 1 or 2 months, you would be safe for this kind of configuration.
Thanks.
That's good.
Yeah, that was fast.
It's kind of an ideal case because it was a very open device with almost no special peripherals that we needed. So it's the simplest case imaginable.
I'm a great fan of NXP and their board support for Android. They are one of the best.
Yeah.
Do you have any? The only other company I can think of that would be comparable would be TI and some of their chips. Anybody have an experience of doing a similar thing with TI? Nope.
But we also like this TI Citara series, so MX62. They're also very nice in terms of just like the overall design and thought throughness of these devices is very, very good.
They're great for smaller scale things. Unfortunately, Qualcomm, for whatever reason, seems to get the big contracts.
Performance and price, I would guess.
Stefan?
Yeah, maybe one thing that, as there's like still a few minutes, that's what was also interesting, or for me especially, was like these generic kernel image stuff. So basically, where there's a promised land where you don't need don't need to compile your own kernel anymore, but you just get it from Google, as far as I understood it. Which also was brought into this project, right? Because before that you couldn't do that, and now you can do that. So that which greatly helps with maintainability, because you basically only provide your device tree and BSP and your kernel modules, but the rest basically is maintained by somebody else.
Yeah, it's the advantages for like let's say like a self-contained products like this are not that big, but like the motivations by Google and the way you develop with a kernel by attempting to boot the GKI is actually very useful, because, as I said, I put the panel driver in a separate driver just so I could do this. But this also leads to cleaner code, because I have my stuff separate from all the other stuff, so I don't actually have to modify code that is also modified by other people, which would then run into conflicts. So it's actually very good mentality to try to support the GKI, even if you don't need that.
Did you talk to Advantech about the changes you were making? Were they at all interested in what you were doing?
Not really. Might have mentioned it like in a small sentence in an email while trying to request some more information from them, unsuccessfully, unfortunately. But we didn't really go to them really talking about that. Hey, we want to do that.
And also, so we didn't have an NDA with Advantech because our customer had an NDA with Advantech for the purpose of actually getting some stuff and also getting the SDK. I think I don't know. We couldn't download it or something. I don't know. They tried to provide it to us, but it was more difficult than you might think. I would just want to put it.
It was easy to just put it ourselves instead of asking.
I think it was running before we had it, if I remember correctly. And that's why we can also not show any code, because the rights to all the modifications are with our customer. So yeah.
Okay.
Could maybe show the GPL parts, but yeah, not the page.
True.
Well, I don't know. Maybe they would be interested in, I don't know, try and persuade them to open source it, perhaps. So kind of leading on from that, then, this obviously is a path that we all have been through, and we keep on following doing these things over and over. Is there anything, what can we do to make this easier? Why is it that BSPs are such poor quality, and how can we improve them?
I think, Google did many things to try that with like the generic kernel image and other attempts, that many names for these products. But in the end, board manufacturers just want to sell you hardware. That I don't think they have much gain from giving you quality software, so they just expect you to do it yourself. The same with all those single board computers from Rockchip and so on. They basically just give you whatever they have, and the rest is your task to, if you want to mainline it, then go on and do it yourself. It's unfortunate, but unfortunately, it's the reality right now.
Stefan?
Yeah, I think actually that actually, like the CIA and other regulatory reasons, are a big push, because before that, also the people that like the end OEMs, I don't know what the English term is, like the people that bring the device into the market, now they have actually an obligation to maintain it, and the question of maintainability is much more relevant than before, and that they will go to the like Advantech and other hardware providers and actually ask them questions. So how do you maintain that in the future? And can you guarantee that to me contractually? And I think that will help. And then their motivation is much higher to try to upstream a lot of things, because what we also see a lot with cheaper manufacturers and also SOC vendors is you see some tries to upstream stuff on LKML or something, and then they see it's hard, and then it just, like the mail, the patch set, the thread just stops at some point, and then they just abandon their efforts. And then there's also, that's why TI is so cool, right? They also now go upstream first, and NXP is also doing a lot, and that I think we will see that much more in the future because of CIA.
Yes, I certainly hope so. And you will be supporting this into the future, I guess?
I hope
or
so.
Your company?
So yeah, so yeah, we will actually continue this project like beginning of next month, and then also maybe we can convince the customer to upstream this. I mean, they know it's in their best interest, but there was just like a hold on the project for some time, and now we will continue.
Okay, that's good news.
There's another question in the chat from Kuldeep. If the GKI fragment is shader code, basically no, it's a confusing naming. It's just a configuration fragment of the Linux kernel. So basically overlay this fragment config on top of the normal GKI config. So it's not related to the GPU.
Cool. Okay. Any other questions before we move on to the next topic? Okay, I'm taking that as we're all done. So thank you very much, Michael. That was a fascinating talk. And yeah, so many of the things you mentioned, ring bells of various sorts, clanging noises anyhow in my head.